So formally, direct variation can be explained as one variable varying directly with the other, or one variable is directly proportional to another. So K is called the constant of variation or constant of proportionality. Either way is fine to say that, but it is a constant, which means it's just a number that's not zero. And that is the number that shows that variation, shows exactly how much those two variables vary with each other. But the direct part is why this is multiplication. Because an increase shows an increase and a decrease shows a decrease, they're going to have the same effect. So let's do some examples of direct variation. Our first example, suppose that y varies directly as x. If y is 24 when x is 8, find the constant of variation and find the direct variation equation. So the clue here on what we're talking about are the words varies directly. That is what tells me this is direct variation. So that first variable equals k times that second variable. That's my translation there. And then the next sentence tells me that y is 24 when x is 8. Okay, so let me put those into this equation. Y is 24 when x is 8. And what that's going to do is that's going to allow me to solve for that constant of variation. And I have to do that because otherwise I can't have an equation without it. So to solve for k, it's being multiplied, so let's just undo that with division there. And that divides to 3. So this is the constant of variation. That's one of my goals, right? So that's done. The other goal is to actually write the direct variation equation. And that is what I had already, but using that constant that I found. So that is the direct variation equation. And I could answer other questions about it, like, okay, suppose x is this, what is y? So that helps me to answer questions, but I have to get that equation first. Another example here, Hooke's law states the distance a spring stretches is directly proportional to the weight attached to the spring. If a 56-pound weight attached to a spring stretches the spring 8 inches, find the distance that an 85-pound weight attached to the spring stretches. So they do want me to find something, right? But I can't find that until I have an equation to solve for it. So in the first sentence, the distance of spring stretches is directly proportional. That's what tells me this is direct variation. So I know I'm going to have some variable equals k times another variable. That's direct variation. But what's that first variable? The distance of spring stretches. So I need to come up with a variable for this. Let me call that d. So d is directly proportional to the weight attached to the spring. Let me call that w. So d varies directly with w. That's my equation so far. Now I need to solve for k. So they have to give me some information here. So 56-pound weight, that's w, attached to a spring that stretches 8 inches. That's the distance d. So this will allow me to solve for k. I just need to undo that multiplication with some division here. And then that divides in 1/7. So that's going to be my constant of variation. Now my direct variation equation, d equals k, which is 1/7 times w. So now I can answer the question, find the distance that an 85-pound weight, so that's w, stretches the spring. So find the d, the distance. Okay. Well, 85 divided by 7. I don't think that simplifies. No, it doesn't divide by 7 evenly. So that's fine. If we wanted to, we could change that to a mixed number. We don't have to, but that would go in 12 times with 1 left over. Either way is fine, but we do have to have a unit here, so let's see. What is distance measured in? Distance inches here. Okay, so it would be 85/7 or 12 1/7 inches. Stretched. Total. Probably the 12 1/7 would make more sense here because it's hard for me to imagine what is 85/7. So I would probably go with that answer. But they're both the same.